Hey guys, Beeler again. Today we're going to talk about proper meter usage. In the previous video, we did some common electrical tools in the automotive world. Today we're going to talk about voltmeter, sometimes known as a DVOM, digital volt and ohm meter. Sometimes guys call them multimeters, ohm meters. We're talking about meters. On this meter, there's a bunch of different settings. So we have a V with a wavy line. That is volts, that is alternating current volts, AC volts. The straight line, DC volts, direct current. That's mainly what we're going to work with on automotive. We go down to little m volts, it's millivolts. The omega emblem is for ohms. There's a beep test, which is good for continuity. Diode test, and we have some amperage tests. This meter will tell you need to switch the leads when you do amperage. I'll show you amperage on a different meter later. But there's alternating current amperage and direct current amperage. We're going to start with voltage. You'll notice down here there's a common. That's where your ground is going to go in, and then over here is our positive lead. They put little indicators on here. So there's volts, ohms, beep test, there's a capacitor tester, and a diode. That's what this plug-in is for. The other one is for amperage, and we'll get to that later. If we're wanting to test voltage, we'd be set on DC volts. We're working with DC on automotive. I've got our test board set up. I've got a diagram drawn out that simulates what we got laid out. So that kind of lays into what we've drawn out on the board so far in previous assignments. We have a fuse, it's our circuit protection device, drawn out on the board. A switch, we've got a light bulb as our load, and our power source is built into the board. So we put the switch on, light bulb turns on. Now, if we're checking volts, let's say it was in a vehicle, we're going to check the battery. We would go positive and negative with the leads. We come up to our positive and negative, and the meter shows 12.07 volts. What we can also check is power up to our fuse. So let's say we don't know for sure if the fuse is bad. We'd need a ground. This board has an extra ground down here. On automotive, you can use engine block or a good chassis ground that's not painted. And we show 12 volts after our fuse. We show 12 volts. Sorry, that was before and after. So if we have voltage before and after the fuse, we know the fuse is okay. If I go to the opposite side of the switch and the switch is off, I show 0 volts. There's no voltage there. If I turn it on, now we have current flowing through, we will show voltage there. As we come to the light bulb, before the bulb, we still show voltage. After the bulb, we've used the voltage up. If the circuit is working properly, and that's the only load in the circuit, that load will use all our voltage up. So if I check on the ground side, we used all but 0.005 of the volt. And that's a pretty good voltage drop across there. So when we talk voltage drop, we're talking about how many volts that part of the circuit used. Now, if we got multiple stuff in the circuit, so like we talk in Ohio, we have corrosion. So I have a resistor here. If I put that in series with our bulb, I've added extra resistance. Get another wire plugged in. You'll notice, if you can see it on the screen or not, we get a very, very little glow from the bulb. That resistor is resisting current flow. Slowed flow down. That means our bulb is going to be a lot dimmer. So now if we check, we still have 12 volts before the bulb. After, we have 9.75 volts left. So the bulb only used roughly 2.5 volts. The rest is being used up at that resistor. The resistor is using up that voltage. So if you're ever checking a component out and you have on the ground side of that circuit, you have voltage left, that means voltage is still left over. It's being used by something else in the circuit. Either corrosion possibly at a ground point, maybe corrosion in a wire. So that'd be a giveaway that we have a corrosion issue. Let's switch this guy back. So back to a good ground, bulb's nice and bright. If it was a blower motor or an electronic device like a motor, they slow down. So bulbs will get dimmer. Electronic motors will slow down if we have resistance on the ground side. Now to measure resistance, we'd switch over to ohms. Now on the meter right now it says OL. OL means out of limits, or overload means there's no continuity right now. It's too high for it to read. If I take my leads and touch them together, I should get close to 0. This meter is at 0.1. Now, when you're using your meter, always touch these together first and see how far off the meter is. It depends on the meter, the quality of the meter, how beat up the meter is, if it's been taken care of or not. If I have resistance, when these two are touching, we want to subtract that out of our resistance when we read a component. Sometimes this can have an effect when you're measuring like injector resistance or a coil resistance. If your meter's off 5 ohms, that can throw off your reading. So our resistor. We'll attach our leads. This is a 99 ohm resistor, 99.1 ohms. This is another bulb just like we're using in the circuit. Looks to be, once he levels out here, we're looking about 7 million ohms. There's a little M next to, well, it keeps moving here. But the M's going to be mega ohms. You can also, the human body, if I touch these, I've got resistance. The human body has resistance. So if you're doing a resistance check, make sure you're not touching your leads. You can throw your resistance reading off. Beep test. So, okay, what's beep test, Beeler? Beep test, when you touch your leads together, they beep. This is great for checking a wire out. So if I got one of my little green wires here, and I don't know if this wire is good or not, I'm testing wires. I can touch here, I touch the other end of the wire, and it beeps and tells me it's okay. This is good for if you're working under a dash or somewhere you can't see your meter. You can see your leads, but you can't see the screen of the meter because you're upside down under a dash. You can hear it beep. So get these guys out of the way. Amperage test. I'm going to use my other meter. This one is from the school. I think the fuse is blown in it on the amperage circuit. When you're doing amperage with these meters, you have to be careful. You can blow the fuse. These things have a fuse built in. This one here, one of my old ones, it's got a 10 amp max fuse in this unit. So if I'm flowing more than 10 amps, I'm going to blow that fuse. So what we're going to do now to do this, when we do voltage, we're kind of tapped in parallel and the circuit's on. Amperage, we need to be in parallel. So we're checking flow. As volts or amperage is flowing through this wire, we have to see how much is flowing through it. So we disconnect the wire and we tap in series with the meter. See the light turn back on, and we are flowing 0.24 of an amp. So that's our amperage measurement. If this was a bigger circuit like a blower motor, I would have blown the fuse in the meter. The fuse is supposed to save the meter. These fuses can be expensive depending on what brand of meter you have. On these meters, so let's say we wanted to check AC voltage. We do alternators, sometimes we'll check for AC voltage, see if we got a problem in the alternator, we're getting AC voltage through. This plug-in back here on our board is AC voltage. If I poke these guys, it shows me 14.5 volts AC. AC voltage is like the stuff in your house. So if you use one of your meters in your house, if you check the outlet, you'd have usually 110 volts. Make sure when you're checking higher voltage stuff, do not touch the terminals, the metal part of your leads. You will get shocked. So make sure you're paying attention. 12 volt DC will not shock you. We get in ignition systems where we're bumping voltage up to 40 to 50,000 volts. Yes, you can get shocked by that. So that's all I have on meters for today. I will talk to you guys next time.